All right, this video is going to go over how to graph cubic functions. Basically, the things you'll need to know are the parent function for a cubic is y equals x cubed. And we're going to be doing some tables. So tables have an x and a y. So for instance, you can input any x value. It doesn't matter. I could input 99 if I wanted. What's important is knowing that you're inputting this x value for the letter x. So like the first one would look like y equals -2 cubed, which is -8. You're inputting the x and getting an output as a y value. So that's how I'm getting all of these numbers. I'm plugging in, like if I plugged in 2 and I cubed it, I would get 8. And by the way, like this -2 cubed part, that's just saying like -2 times -2 times -2. The same thing times itself 3 times. That's what a cube is. All right, so what happens is it takes this shape on a graph when you graph all these coordinates. It's almost like a curved line, kind of like this. So that's what the parent function for a cubic looks like. Now we'll get into all these transformations and stuff and how to do all those as well, but let's look at some attributes first. You need to know on a cubic function, it's really going to go like this, and like this. So what that means is it goes left forever, right forever. So my domain is all reals. And if you look at it, it goes down forever, up forever, which means my range is also all reals. The end behavior, it works like this. You're going to have one that goes x goes to -infinity, and then you're going to have one that goes x goes to +infinity. And you'll have y going to something for both of these. Now, the -infinity one, x going to -infinity, means if you go left on this line, so like this arrow right here is the one that's going left, and it's going down. So my y values are going to -infinity. And then if you go right, that's x arrow +infinity. That's this guy right here. He's going up to +infinity. So that's how you do end behavior. And I'm sure I have another video on end behavior if you're struggling with that. Then increase, decrease. Cubics are only going to have one of these. So you read it like a book, left to right. And if you look at this line from left to right, it is going up the entire time. So there is no decreasing on this particular line. It is increasing. And then you're supposed to ask yourself, from what x value to what x value? Well, that'd be an x value of -infinity to +infinity. All right. Now, that's not a realistic problem. That's just the parent function. These are what the realistic ones look like, okay? So basically how I'm going to do these is I'm going to set up an XY table. And I'm going to go get my vertex. Here's my vertex. And it's like your HK. Sorry, it's not vertex. I keep saying that. It's axis of symmetry. Axis of symmetry. It's like your HK. It's kind of like the vertex of a parabola. It's where it flip-flops. It's the spot in the middle right here. It's where the line flip-flops. Anyways, I'm going to go get that and put it in my table first. So h lies, so it's really -2. And the k is -3. So I know I have a spot at that hk, -2, -3. Well, what about the other dots that I'm going to need? Well, here's how I'm going to do this. I'm going to go backwards a little bit, so -3, -4. I'm going to go forwards a little bit, so -1 and 0. And I'm going to, just like before, I'm taking this x value. So for instance, -4. And I'm plugging it in right there for the letter x. That was an awful line that I drew. It's going to plug in right here. So it's going to look like this. Y equals negative parentheses, x changes to be a -4. And if you work this out, you'll get y equals -4 plus 2 is -2. Cubed is -8. And then it's like -8, which turns into +8. -3 is 5. If you're not sure, use a calculator. So that's how I'm going to do all of these. So that's how I'm going to get all of these y values. So like the next one, I'm plugging in -3 into it, and I would get -2. Okay. Then I'm plugging in -1, I'm getting -4. And when I plug in 0, I get -11. So now I have some coordinates that I can plot. -4, 5. Okay, if this would stop jumping. -4, 5. -3, -2. -1, -4. And then the other one's down here at -11. So this is what this line looks like. Ta-da. Nothing to it. As long as you really understand the whole plug in an x value, get a y value, you're going to be fine at this. So it goes left forever, right forever. My domain's all reals. It goes down forever, up forever. So my range is all reals. In behavior, if I go to the left, that's this arrow, it is going up. So y is going to positive infinity. And if I go to the right, that's this arrow, I'm going down to negative infinity. And then increase, decrease from left to right, this line is only decreasing, so there is no increasing. And it's decreasing the entire way from negative infinity to positive infinity. Just like that. Okay. Let me show you all that again. I'm going to start by getting my HK. So remember H lies, so it's at 1, -4. So in my table, that's going to be my middle point, 1, -4. Now I'm going to work backwards a little bit. So x value working backwards from 1 would be 0 and -1, and working forwards would be like 2 and 3. Now I'm plugging in these x values. So like the first one I'm going to plug in is this -1, and it's going to go right here. So it's going to look like this. Y equals -1 minus 1. Sorry, I forgot a 3 in the front. Y equals 3 times -1 minus 1 cubed minus 4. So let's see, that's -2 cubed is -8 times 3 is -24 minus 4 is -28. That's how I'm getting these values. So like the next one, I would be plugging in 0. I would get -7. If I plugged in 2, I would get -1. And if I plugged in 3, I would get 20. So now I'm going to put these dots on the line. 0, -7, 1, -4, 2, -1, and then the other ones don't fit. So it's going to look something like this. Now be careful, it is not a straight line. So you can't draw it as if it's a straight line. It just doesn't look good on this one because it's kind of stretched out. Okay, domain all reals, range all reals. I've talked about why that is. In behavior, if I go left, it goes down. If I go right, it goes up. This line is only increasing. It is not decreasing, and it's increasing from negative infinity to positive infinity on the x-axis. Okay, now we get to the tricky ones. This is where you're probably going to want to have a calculator handy. I have one handy, so if I'm even using a calculator, maybe you should too. Now, I would start by going ahead and getting the point of inflection. So that's at -3, -1. All right, now that's going to go in the middle of my table. So work backwards, it's going to be -4, -5. Work forwards, -2, -1. Now to get these values, again, I am just plugging in these x values in for the letter x right here. So when you plug in -5, you're going to get 0. When you plug in -4, you get -0.875. When you plug in -2, you're going to get -1.125. When you plug in -1, you'll get -2. All right, now throw them onto the graph. -5, 0, -4. -0.875 is like -1, almost, not quite. So it's like here. -3, -1, -2, a little over -1, and then -1, -2. So this thing's really stretched horizontally. It's not going to look pretty when I draw this, but it would look something like this. And the reason it doesn't look pretty is because it got stretched horizontally so much. Okay, this next one. Start your XY table. Go get your point of inflection, which there's no shift here, so your H is 0. So this one's at 0, 2. That's what's going to go in the middle of my table. Work your way backwards, so -1, -2, forwards 1, 2. You're going to be plugging in these points. So when you plug in -2, you will get -62. When you plug in -1, you'll get -6. Plug in +1, you'll get 10. And then 2, you'll get 66. So only a couple of these fit on this graph. Let's see, it looks here, 0, +2. 110 doesn't even quite fit. So this thing really got, we'll call it compressed horizontally. So it looks something like that. All right, now this last one, here's how you're going to do this. You're going to, first of all, you have this equation, y equals a 1 over b x minus h cubed plus k. All right, now the first thing you want to do is find this vertex here, which is at -2, -2. So remember, your h is lying to you. Oh my gosh, just zoom in. Thank you. Your h is lying to you. So we don't know a or b or anything, but we know this part has to be x plus 2 cubed. And then minus 2, because we knew this hk. And since h was lying, instead of writing -2 in the equation, we write +2. Now, what you're going to need is to realize, like, this right here, this is a jump of 3 from one dot to the next. That's kind of like your a value. This is the hard part to find. There's mathematical ways to do it where you can plug in x and y and solve for a. I don't feel like doing that. I'm just going to look at it, realize that my first jump went up 3. So I'm just going to call it 3. Now, if this line had looked like this, I would have put -3 because there was a reflection there. But since it just mirrors what a normal cubic function looks like, you can just call it +3. I hope that made sense. Your teacher will probably get mad at you for doing it that way, but sorry. Okay, well, that's how I graph these. It's mainly plug in an input for the letter X and get you an output and make coordinates out of those. It's super important that you're able to do that. Hope this video helped.